Hello, students. Today I will begin a very important section of physics, electronics and semiconductor devices. In present days, when we see around us, we find so many electronic gadgets that has made our work and life so easy. For example, mobile, which has become an inseparable part of our life. It has become a tool for gathering any type of information. Even this lesson you are able to see using mobile, tablet or computer. All these gadgets have come into existence due to knowledge of electronics and semiconductor. Earlier we knew about two types of materials, conductors and insulators. But with the knowledge of semiconductor and the inventions related to this has changed the way of human life, and it has revolutionized the communication system. So today first we will understand what is semiconductor. In simple words, we say that a semiconductor is the material having conductivity less than that of a conductor and more than that of an insulator. But for understanding the difference between the conductors, semiconductors, and insulators, we have to learn a little about the band theory of solids. We know that in an isolated atom, the electrons occupy well defined energy levels. In a crystal, where there is a large number of atoms, they influence each other, and due to interatomic interaction, there is considerable modification in the energy levels of the electrons in the outer shells. The result is the valence electrons are shared by more than one atom in the crystal. As the interatomic spacing or distance in crystals is very small, there forms two bands of energy with an energy gap. The lower band, which is completely filled with electrons, is known as valence band, and the upper unfilled band is called conduction band. The gap between these two is called forbidden energy gap or band gap. Valence band is never empty. Electrons in this band do not contribute to the electric current. Conduction band is empty at 0 Kelvin or partially filled with electrons at atmospheric or room temperature. Electrons in this band contribute to the electric current. Forbidden energy gap is completely empty as there is no electron in this gap. In fact, the minimum energy required by an electron to jump from valence band to conduction band is the band gap, and it is denoted by Eg. So Eg is equal to h nu or hc by lambda, where lambda is the wavelength of radiation used to shift electrons from valence band to conduction band. And as you know, c is the velocity of light and h is the Planck's constant. In metals, the conduction band is partially filled and there is a large number of free electrons, which after gaining even a little energy from outside, begin to flow through the metals. Hence, the conductivity of metal or conductor is very high. In conductors, there is no band gap and the two bands overlap each other. In insulators, valence band is completely filled, but conduction band is completely empty. And there is a very large forbidden gap of the order of 6 electron volt. Due to such a large forbidden gap, no electron is able to shift from valence band to conduction band even after gaining energy from outside. Hence, no electron is available in conduction band for electric conduction, and thus the material is poor conductor. In semiconductor, valence band is completely filled and conduction band is empty. The forbidden gap is very small, of the order of 1 electron volt. At absolute zero, that is at 0 Kelvin, electrons are not able to cross even this small gap, and hence semiconductor behaves as insulator at 0 Kelvin. But at room temperature, some electrons acquire thermal energy enough to cross over the band gap and jump to conduction band, where they are free to move. Therefore, semiconductors acquire small conductivity at room temperature. So we see that if temperature of semiconductor rises, its conductivity also increases. Whereas in case of a conductor or metal, with increase of temperature, the conductivity decreases. There are two elements which are semiconductors, silicon and germanium, both from group 4 in periodic table. All group 3,5 compounds and various other compounds are semiconductors. For silicon, energy gap is 1.1 electron volt, and that for germanium is 0.72 electron volt at 0 Kelvin. In semiconductor, the conductivity is not only due to flow of electrons in conduction band, but it is also due to movement of holes in the valence band. Let us now understand what is hole. When temperature is higher, some of the electrons gain enough energy to cross the energy gap and shift to the conduction band, leaving behind vacancy in the valence band, which is called the hole. A hole is considered as an active particle with the same quantity of positive charge as an electron in the conduction band. Hence, the motion of electrons in conduction band and motion of holes in valence band both contribute to the electrical conductivity in semiconductors. We can understand the formation of holes through valence bond concept. The crystal of silicon or germanium have 4 valence electrons. You can see in the diagram of a structure of germanium crystal in which every atom of germanium shares one of its 4 valence electrons with each of its 4 nearest neighboring atoms to form covalent bond or valence bond. At higher temperature, some atoms get ionized and hence some valence electrons break out the covalent bond to become free to move in the crystal, leaving behind empty space with equal amount of positive charge called hole. This position of hole may be occupied by another electron from a neighboring atom, creating a hole at another place. This way, hole can also move from one side to another. With breakage of each covalent bond, one free electron and one hole is available in the crystal, for which ionization energy equal to Eg is needed. Hence, with the rise of temperature, conductivity of semiconductor is increased. Silicon and germanium are intrinsic semiconductors. Intrinsic semiconductor is a pure semiconductor. There is no impurity in it. In intrinsic semiconductor, number of free electrons and holes is exactly same. The intrinsic semiconductor is not of much use, as the charge carriers, that is electrons and holes, are not much at room temperature. To make a semiconductor more useful, some impurity is added to it. and the process is known as doping. Doping is a process of deliberate addition of desirable impurity atoms to a pure semiconductor to modify its properties in a controlled manner. The impurity atoms added are called dopants. In the process of doping, the dopant atom takes the position of semiconductor atom. By doping a semiconductor, its electrical conductivity is increased to a great extent. The doped semiconductor is called extrinsic semiconductor, and we will discuss this in the next class. See you in the next class.